Chapter 10, Anticoagulants, Water Treatments, and Fragrances. So we're still looking at carboxylic functional groups. And we're going to look at carboxylic acid and esters in particular. And so as you see, the difference is what is attached right here, where remember this R group could equal carbons, multiple, it could just keep going. It could be any number of carbons. So as I said, we're going to look mainly at esters and carboxylic acid in this chapter. The other ones listed here we're going to look at in chapters down the road. So carboxylic acid has that COOH group. So remember here we've got a C, and then here's one O, and here's your OH that's attached to it. So they are true acids because they dissociate in water, so they're soluble in water. They can form a conjugate base and a hydronium ion. They are considered to be weak acids, so remember that was where they do not completely dissociate. So here you've got your conjugate base that's formed, and then you have that hydronium ion that's also going to be produced. So the only acidic hydrogen is going to be the one that is attached to the oxygen. So it's this one right here. That's your acidic hydrogen. When you name carboxylic acids, they are going to have an IUPAC name, and so they're going to have those prefixes that we looked at before, meth or math in this case for 1 carbon, eth for 2, prop for 3, bute for 4, and pent for 5. And then you've got your common names, which is going to be more beneficial for you to know, probably more useful. So formic acid, that's found in some insects in their bites. Your acetic acid is your vinegar, Vinegar is a type of acetic acid. So those are your acids from carbons 1 through 5. And then here you have those same acids that if we, which you have an acid, and then if we react it with a base such as sodium hydroxide, then we end up with a salt and water. So HOH is the same thing as H2O. So in the chart below you have the naming of these same 5 acids after they've reacted with this base. Then they're all going to end in the suffix ATE and have sodium as their first part of their name. And then you've got the root name that we saw before. So your sodium formate is found in food additives and preservatives. Sodium acetate, another preservative or seasoning rather. Sodium benzoate is going to be found in a lot of different products. Salad dressings, carbonated drinks, pickles, also in medicines and cosmetics. If it's a polycarboxylic acid, then remember poly means many, so you're going to have at least 2 or more carboxylic acid groups. So oxalic acid is where you just have 2 carbons, and then your malonic acid 3 carbons, succinic acid 4, glutaric acid 5, and adiptic is going to have 6 carbons. So oxalic acid was the first one we were looking at. So it can be converted into disodium oxalate. By adding the base. So you got a strong base, which is an example of that would be sodium hydroxide. So it was first used as a water softener or anticoagulant, and that's what's going to be important for us in funeral services. It fell out of favor because of toxicity concerns. So it, when soluble sodium oxalate is the modifying agent, then calcium oxalate precipitates out of solution when added to the hard water. So just like if we were trying to control hard water, then our acetic acid, or around the house, or vinegar, reacts with hard water deposits such as calcium and is going to create a water-soluble compound, calcium acetate. So in funeral service industry, the tricarboxylic acids are going to act as sequestrant anticoagulants. So the citrates, though, fell out of favor because they were found to promote the growth of bacteria, which actually causes the blood to clot. So we did away with that, and your potassium citrate is that one that we did away with. EDTA, or ethylene diamine tetraacetate, is colorless, water-soluble polycarboxylic acid. It is the conjugate base that is going to be of most interest to you because it is a sequestrant anticoagulant. It cages the metallic ions but keeps them soluble, so they're not going to precipitate out. So EDTA is able to sequestrate the calcium ion, and it's also going to engage a chelating agent. And so chelation is just a fancy way of saying that it wraps around the calcium ion. And interesting as well is that EDTA is used for lead or mercury poisoning because it helps get rid of those heavy metals, and it's called a chelation therapy. Esters are the other type of group that we were looking at. So instead of the OH, you've got OR. And so esters like triglycerides, we find those in animal fat and vegetable oils, which are really important to monitor your intakes of for your nutrition. Esters are present in pheromones in the animal world. Here you have the structure that has the pheromone that's in catnip. We know what that does to cats, and it says humans do not technically respond to pheromones, but our perfumes and colognes have esters as functional groups. So there is a reason that we put that in there. One of the fragrances that's going to be of most interest to you is going to be wintergreen, or wintergreen is also known as methyl salicylate. It's very similar to aspirin, which has the chemical name acetylsalicylic acid. It has a very distinctive odor. If you've ever used your analgesics such as this Icy Hot here or Bengay, It's another type of analgesic that has that methyl salicylate in it. It has a very distinctive odor. It also has also been used in things like, I remember in my childhood, wax lips. Halloween, for example, you might have wax lips to dress up and act silly, and it had the flavoring of methyl salicylate. So here we have a thioester. So says it's the first cousin to the ester. So like all sulfur containing compounds, it has a very disagreeable odor. So most sulfur compounds have a very distinct odor. Some individuals are allergics and they have to stay away from things that contain sulfur. So here we have the acetyl coenzyme A, which is important in metabolism. We find it in Krebs cycle.